Okay, girls, so for our last exercise for discrete probability, we're looking at variance and standard deviation. So basically what standard deviation is, and that's what we want to find, is basically a number that shows how spread all of these scores are from the mean. Okay? So don't worry about all these details. Let's just get on to this question. So if I want to know how far off each and every individual scores are from the mean, obviously we need to find the mean, right? So let's find the mean, and we learn how to do that. And remember, mean can be symbolized as mu or e of x, okay, which we learned last lesson. So let's do that. To find the mean, remember, you get the outcome times by the probability plus, keep going. Yep. So if I put all of this in the calculator, it is 2.46, okay? Now, if I wanted to know how far this score is away from the mean, wouldn't it make logical sense to get the score and take it away from the mean, because I wanted to know how far it is off from the mean? And because it comes with a probability, I'm going to get this and then times it by the assigned probability with it, okay? Now here's one thing though. See the difference between the square and the mean? You have to square it, because if you notice, one takeaway that's going to give you a negative number. And by you squaring it, it will always turn into a positive number. Okay, and later on, because we squared it, we are going to square root it, so don't worry. And then I'm going to keep adding on, and then we want to find out how spread these scores are, each and individually from the mean. Okay, so let's take the next score 2. And we obviously want to know how far that score is off from the mean, so I'm going to take it away from the mean. Okay, and once again I'm going to square it, because that's going to give me a negative number. Because if you realize, average of all scores of the mean is always a positive number. So just like how the mean is always a positive number, standard deviation is always a positive number. It will never be a negative number. Okay, keep that in mind. So that's why we're squaring it. Times by the probability. And I'm going to keep going, plus 3, take away the mean, squared times the probability, plus, now next one is 4, take away 2.46 squared, times by the probability, okay? By you doing this, okay, what we're actually finding is the variance, okay? And variance is symbolized by this, var x. And if I put all of this in the calculator, you'll get 0.7684, okay? From here, you use the variance to find the standard deviation, okay? So, standard deviation, which is symbolized as that, because we squared it, all you need to do with the variance is square root your variance number, okay? And if you do that, you're going to get 0.8766. That's your standard deviation, okay? Standard deviation. Alright, so what that means is, on average, all of these scores with the assigned probabilities are that much off from the mean. That's what that number is. Now, see how I took a very long time to do all that working out to find the variance, to find the standard deviation? So let me make it clear. To find the standard deviation, you find the mean, and then you find the variance, and then you use the variance to find the standard deviation. The standard deviation is what we want to ultimately find, okay? Now, this whole thing, see how it's a really long set of working out? There is an easier simplified version, which I'll show you now. So what you do it in black. So, variance is, instead of you doing the score, take away the mean, you do just the score, okay, times by the assigned probability, okay, and then plus the next score squared times the probability plus the next score squared times the probability plus the last score squared times the probability, and then at the end you take it away by the mean squared. Okay, that's the mean, remember? So if you put all of this in the calculator, you'll get the same thing as 0.7 684. Okay? The reason why this works, there is a reason behind it. It's a really long proof, but you don't need to know it. But if you're really curious, you can have a look at the really long proof working out in your textbook, but you don't need to know the proof, okay? And it's just a lot easier to work out this way than this way. Either will work, but obviously this will be more practical in most of the situations. All right? So this is what I've just done here. This is what this fancy formula means, okay? You're taking the score of each, okay? Now, E of x squared means you also have to times by the probability of each outcome. So this is all of this, okay? Take away the mean squared at the end, okay? So that's what that formula means, and that formula is actually in your formula sheet, okay? So that's how you use it. This is not in your formula sheet, so you just got to know to square root your variance to find the standard deviation at the end. Okay, so obviously from here we will ultimately want to find the standard deviation, which you just do by square rooting that number. Again, you'll get the same thing as what I had previously. Okay, now this can be done using a calculator as well, but like I wrote there, you need to know how to calculate it with and without a calculator, because I'll show you later on after this example. There are some questions where there are no numbers and it's just all in terms of letters, so algebra. So you need to be able to do this because you can't use a calculator if it's in terms of algebra. So let me just quickly show you how to do it using a calculator. With a calculator though, you won't be able to find the variance, you'll be able to find the mean and the standard deviation only, okay? So to do this, I'll just quickly show you. You press mode 2 and then 1, okay, and then type in all the top row, so 1 equals, 2 equals, 3 equals, 4 equals, and then go to the side in the frequency column and press the bottom button to go back to the top, and type in 0.16, which is the probability, equals 0.32 equals 0.42 equals 0.1 equals. Once you've done that, press AC to get out, and then press shift 1 4 for var, variance, and then you'll see here 3, that's a symbol for the standard deviation, which is 0.876, which I have, okay? You can also use that, if you press shift 1, 4 again, 2 is your symbol for the mean, which you can see we've got 2.46 on the board as well, okay? So you need to be able to do both methods. Now let's have a look at a question where we've got algebra instead of numbers. Okay, so basically the question says find the variance of this. You need to keep in mind, it doesn't say find the standard deviation. Sometimes they'll just ask you to find the variance, not the standard deviation. So to find the variance, remember the first step is to find the mean. So let's find the mean, E of x. Okay, so in this case, remember that's just the number times the signed probability. So that's minus 1p plus the next number 0 times the signed probability 2p plus 1 times 1 minus 3p. So my mean is minus p plus, that's just 0, 1 minus 3p. So if I do that, that's minus 4p plus 1. So that's my mean, okay? E of x or mu. Now to find the variance, var, okay? Remember, you have to square each score, put them in a bracket, times by the assigned probability, plus the next score, which is 0 squared times 2p, so it doesn't really matter here, plus 1 times the assigned probability, and at the end, take away by the mean squared. So I'll put in a bracket. So that's what you need to simplify, okay? So this is p plus that is 1 minus 3p. So that's your answer, okay? So this is your variance x, okay? So the answer is D. Okay, girls, so do I need to show any more examples? I'll just go through one more example from your textbook. It says, in a game, 2 cards are drawn from a deck of 52 standard playing cards. A player wins 5 points if one of the cards is an ace and 10 points for double aces. A, if random variable x is the number of aces drawn, so in other words, so the top numbers are the number of aces drawn, create a probability distribution for x. So the number of aces, if you pick 2 cards, you can get 0 ace, 1 ace, or 2 ace. Now we've got to get the probability. Remember, it's multi-stage event here, so let's draw a tree diagram. We can get ace or non-ace for our first pick. How many aces are there in our deck of cards? There are 4, okay? That means for non-ace, that'll be 52 take away 4. That's 48 over 52. Now for a second pick, draw another branch. A, non-ace, ace, non-ace. So if I pick ace in my first pick, then I'll have 3 aces left out of 51 cards. Number of non-aces will stay the same, 58 out of 51. Non-ace to another non-ace, that's reducing 48 by 1, so 47 out of 51. And ace would be still 4 out of 51, okay? So do this, and then get the numbers for double ace for 2 by multiplying these two. For number of 1 ace, that will be this number plus that number, and no ace would be this, okay? Get the numbers for those, and then find the mean, variance, and standard deviation from the table, okay?